Hi guys, welcome to your Thursday maths lesson. Today we're going to develop our arithmetic skills. Including today's lesson, we have 3 Thursdays remaining. So we're going to take each of these Thursdays as a chance to recap lots of our arithmetic skills that we have looked at and developed already over the last 12 months in preparation to get us ready for our transition to year 6, which is just around the corner. How's it going to work then? I'm going to talk through 10 arithmetic style questions. You're going to look, watch on, and take it all in. And once I've gone through my 10, I'm then going to set you 10, at which point you're going to pause the video, work through the 10 questions, and then at the end I will go through the answers to allow you to check yours and see whether you got 10 out of 10. So that's going to be the structure for the next 3 weeks, or the next 2 weeks after today, of maths lessons. Question number 1, 3/10 subtract 10 quarters. I am doing a subtraction. So I would always subtract the operation, just as a little technique, just to allow me not to make silly mistakes. Particularly under pressure, if you're doing these in tests and stuff, it's easily done where you find the common denominator and then you add rather than subtract, or the other way around, which is really infuriating because you've done all the maths correct, it's just that you do the wrong operation. So maybe get into the habit of circling the operation like I've done there. Next thing, find the common denominator. I'm going to use 40 as my common denominator. I can do that quite quickly without too much thinking because 10 is a factor of 40. I can times 10 by something to get to 40. So I can just use my large denominator. In year 6, you'll take this on a bit further and look for more trickier common denominators when you get into your fraction work next year. What did I times 10 by to get to 40? Because I do the same to my numerator as I do to my denominator. I times it by 4. 4 times 3 then would give me 12. The second fraction remains the same because I've times them both. I've times the denominators by 1. So the numerator gets times by 1. And then I just merely subtract looking at the numerators because my denominators are the same. And it gives me 2/20. Sorry, it doesn't. It gives me 2/40, which can be simplified, preempting myself a little bit there, into 1/20, because they're both divisible by 2. So question number 1 is a subtracting fractions question, as will yours be in a few moments' time. Question 2, 7,408 subtract 29. Now, a lot of people might be tempted straight away to go into the column method for subtraction. Doing that is fine, however, it requires quite a number of exchanges, which can sometimes lead to really silly and sloppy mistakes being made. Because I've got a number, a near tens number, 29 being near 30, I can subtract 30, so I could subtract one more than I need to, and then I could add on that one extra that I subtracted to give me my final answer. So if you ever get a question like this, look and think, can I subtract something quite quickly and easily in my head? And if you can, do that, because it just quickens you up and it just kind of takes out that problem of doing lots of exchanges, which is what you would have to do if you did it in the column method. So subtracting 30 would get me to 7,378. Because I subtracted one too many, however, I need to add on that one to give me a final answer of 7,379, which is what my answer is to my original calculation. Your question number 2 today will require you to take away a near tens number and use this method to then add on 1 to give you your final answer. Question 3, 27 add 13 equals something times 4. So the calculation needs to be balanced on both sides. That's what that's what equals, which is here in the middle, means. It needs to be balanced. It needs to be the same on both sides. So this side here, I can see equals 40. I can do that quickly by adding 20 and 10, which gives me 30, and then 7 and 3 is a number bond to 10. So add them to answers would give me 40. What do I times by 4 then? To make it equal on this side, I times it 4 by 10. I then have an answer now that equals 40 on both sides of my calculation. Your question number 3 will require you to do something very similar. Question number 4, timesing multiples of 100 together. Nice and quickly, to answer these questions nice and quickly would be to add the 2 digits that you can see greater than 0, which in this case 1 times 2 is, and then look at my zeros and think how much greater do I need to make it, because at the moment I've just done 1 times 2, but clearly the calculation is much bigger than that because I've got 4 zeros, so I need to make my answer 1,000 times bigger than it was originally. To make it 1,000 times bigger, I add my 4 zeros because I'm moving my 2 4 places to the left. Put my comma in, I've got a 5-digit number, so I know it's a 10,000 number. I've actually got 2 lots of 10,000, so my final answer in this case is 20,000. You'll have again something similar, timesing the 2 digits that you can see mentally in your head, and then timesing that answer by a multiple of 100 to give you your final answer. Question 5, halfway there for me. 3 cubed, or anything cubed, means the same number times together 3 times. The misconception can be sometimes to times it by 3. That isn't what you need to do. Cubed numbers, so in this case it's 3 cubed, so it's 3 times 3 times 3. Well, I know that 3 times 3 is 9. So then what I do with my 9 is then times it by my final 3, which gives me 27. So just to recap, cubed, the number times the number again, times the number again. Question 6, timesing by 2, which essentially is doubling, isn't it? 6,145. I would, in these sort of questions, partition. So I'd partition the 6 or 6,000, which partition it and double it. That's what I'd do. Yeah. So I would partition the 6,145 into 12,000, because double 6,000 is 12,000, 200, because double 100 is 200, 80, and 10. I would then put my partitioned doubled number together as 1. So I would have 12,000, 200, and 80 add 10 is 90. 12,290. So partitioning, but doubling as you go, and then putting the number together to give you your final answer. Question 7, 1 add something, oh, sorry, 1 equals something add 0.1. I'm going to use my fractions, decimals, and percentages lesson here to help me with this. So 0.1 is the same as 1/10. 1 whole, if I'm thinking about tenths, is the same as 10 tenths. It's one of those calculations where I've got to make it balanced again. So what do I add to 1/10 to make it equal to 10 tenths? This side's 10 tenths. I add 9 tenths. 9 tenths as a decimal is 0.9. Question number 8. 628 add something gets me to 851. So I know what my answer is, I know what one of my parts is, but I'm looking for the difference between. So I'm going to, in my head almost, if you can, picture a number line. 628 at one side, 851 at the other. I'm going to try and jump from 628 to 700. Well, if I add 2 to this number, it would get me to 630, and then 630 to get to 700 would be 70. So in total there, I'm adding 72. 700 to get to, if we go to 800, is a further 100 added on. So you can see there's a bit of working out here. You might be able to in your head. If not, you might want to just do a little few jottings like this, but using the number line method. And then 800 to get to 51 is adding on a further 50. So then I'm going to do 72, add 100, which is 172. Add on my 50. Gets me to 222. Add on my 1. Get me to 223. Find the difference using a number line will be your question number 8. Smallest number at the left hand side, the large number at the right hand side, and then trying to do some manageable jumps to get from here to here. Question 9, penultimate question for me. Fraction of an amount. 84, that's my largest number, that's my large number. Divide it by my denominator, which in this case is 12, will give me an answer of 7. Add then to my answer times the numerator, which is 5, to give me a final answer of 35. Whole number divided by the denominator, and then your answer times by the numerator. Finally, 3/4 and an 8. So again, I am doing one of my 4 operations. So I'm circling it to make sure I don't do something silly at the end. I'm going to use 8 as my common denominator because 4 is a factor of 8, similar to question number 1 this. But I'm doing add rather than subtract. How do I get from 4 to 8? I times it by 2. So I do the same as my numerator. 3 times 2, which is 6. That remains the same because I'm timesing it by 1. And then I put the 2 answers together to give me an answer of 7 eighths. 7 eighths is my answer in here. Okay, that's my 10 done. I'm now going to set you 10 very similar ones. So there they are on the screen, very similar to what we have just gone through. I'm going to ask you to pause the video, have a go at doing the 10 questions, and then come back and we'll check your answers. Pause the video now. Question number 1 then. You're doing a subtract, so circle it, put your subtract sign in straight away. 18 is your common denominator. Because I can times 6 by 3 to get to 18. 5 times 3 is 15. Second fraction remains the same because I times them both by 1. Answer can be 10/18. They're both divisible by 2, so I can divide them both by 2 to give me my answer in its simplest form, 5/9. Did you get it? What we did, either one of these 2 answers would get you the mark. 1. Question number 2. 8,504 subtract 30. Well, subtract 40 would get you to 8,464. Because I added, or I subtract, should I say, 1 too many, I need to add on 1 at the end to give me a final answer of 8,465. Question 3. Balance on both sides. So this side equals 60. 10 add 40 is 50. 6 add 4 is 10. So 60 in total. What do I times by my 5 to get to 60? I times it by 12. So it's balanced on both sides because both calculations equal 60. Question 4. Timesing 2 multiples of 100 together. So 7 times 5, nice and easy, because we can do that using our mental maths multiplication skills, is 35. I've got 4 zeros, so I need to make my answer 1, 2, 3, 4. So I actually need to make my answer 10,000 times bigger. And my final answer would be, oh, sorry about that, 350,000. Question 5, 4 cubed. 4 times 4 times 4. I know that 4 times 4 is 16. 16 times 4 is 64. 4 cubed is 64. Question number 6. Partitioning. I'm doubling. So double 8,000 is 16,000. Double 300 is 600. Double 20 is 40. Double 4 is 8. Add your answers together. 16,648. 5-digit number. Let's put my comma in there. That's my final answer. Question 7. 1 whole equals something and 0.6. 0.6 is the same as 6/10. 1 whole is the same as 10/10. So I need to find the difference between the two, which is 4/10. 4/10 written as a decimal is 0.4. Question number 8. 458 add something gets me to 672. Small number at the left-hand side, larger number at the right, and I'm going to jump from here to get to 500 by adding 42. $500 to get to 672 would be 172. Oh, I just spotted a little mistake. Make sure you added 32. You have added 32 there. The difference between 460 and 500 is 406, sorry, and 500 is 32. Add them both together. What am I doing? I've made a mistake. I was right, wasn't I? Yeah. There you go. See, you teach have off days sometimes. Right. So I've now got 172. I add my two numbers together, which would get me to 214. Dear me. Hopefully you did that a bit clearer than I did. We got there in the end. 214 is definitely the final answer. So 458 add 214 gets to 672. Right, 39 divided by 13 for this answer. Let's see if I can get through it without getting myself in a tangle this time. 39 divided by 13 is 3. And then I need to do 3 times 7, which is my numerator, to give me 21. 21 should have been your final answer. And then finally, 3/7 out of 1/28. 28 is my common denominator. Times 7 by 4 to get to 28. 4 times 3 is 12. Add them together. The second fraction stays the same. Will get me to 13/28. Anyone get 10 out of 10? Absolutely brilliant. If you did, well done. I'm going to leave it for today. There's no other work to do for today's maths lesson. Catch up on any My Maths if you have any outstanding tasks from this week. Tomorrow will be the problem solving lesson, where you have a go at the 5 challenges, I think it is. So I will see you in the morning to go through them. Have a great day.